Okay, I will start. So this uh, data mining course is about data pre-processing. Oh wait, I think I haven't finished the last one. Uh, the last section we deal with the data visualization. I guess the remaining part is only a few things that yeah, it is just for the I think at the time I finished until this part when we want to visualize complex data and relations. Okay, yeah, we can have some additional visualization approaches like this one. If we want to visualize non-numerical data, so if we have text data, and then if we have social network data, and then nowadays we have that tech, so we can use tech, and then the tech cloud. Yeah, it means we want to visualize the user generated text. So we can use this kind of we call it, this is the news map. Okay, so news map is for the social network and related to the text, and it's also possible for extracting the news. So the bigger size of the font affect to the important level. So maybe this is important. Okay? This is less important. Okay? And the smaller one maybe is very low importance. So the important means the number of viewers, okay, or the number of people who like this news, or the number of people who read this news. Okay. So that kind of things can be visualized like this one. And maybe the brown color is related to, yeah, the politics. Maybe the purple color is related to maybe economics and etc. So the color can represent with some topics. Yeah, we can also deal the complex data and relations with graph. So this is a kind of graph to see the relationship between the disease. This is the disease influence graph. So there is a data set. This is the data set name, NHANES. So you can see, yeah, HP is the high blood pressure, AL is the allergies, OV, overweight, and so on. And they want to put it in a graph whether there is a high correlation between one disease with another disease. Let's say HP. Okay, HP is the high blood pressure. It has a high correlation or is very close related with this arthritis, AR. And it is also highly correlated with, it's closely related with OV, overweight. Then you can see easily how they are correlated if we have all the data, and this visualization can give you directly about the patterns or directly about the relationship among the diseases. Okay, so I will use the rapid miner a little bit later to show some of the visualization. So now let's go to the data pre-processing first. So in this section, we are going to discuss 4 key points. The first is data cleaning, and next is data integration, and then I will discuss the data reduction and transformation in another PowerPoint. First, I can say that those 4 are the major tasks in data preprocessing. Yeah, actually there are many smaller keywords for the data preprocessing, but based on some literatures, those 4 are the major tasks. Data cleaning. What is cleaning? So we say clean. It is to remove the dirty data. So the dirty data, what is dirty data? For example, missing values. Or if there are some noisy data, we want to smooth it. Or if there are some outliers, we want to remove it. Or we want to resolve inconsistency. Okay. Data integration. So if we have many databases, so we need to collect it into one table. Then how we can integrate that one? Data cubes or files is also related to how to integrate data. Data reduction. When we have dimension, okay, so dimension, if you still remember, it is related with the table. Okay, so the dimension means the column. Dimension means the attribute. Okay, the dimension means the feature. Dimension means the column, or dimension means the variable. If the columns are a lot, it will be so complex to analyze the data. So sometimes we need to reduce the data because some of the columns is not important. Some of the columns are not reliable for the analysis. So we can remove it. Or we can do the numericity reduction. If you have a lot of rows, okay, if you have a lot of rows, your computer might not be strong enough to compute. So you need to remove or you need to delete some data. Or in the data mining, we have also data compression. So for example, if you have image, okay, maybe your smartphone now is good enough, so you can save all the images. But when you send the data or when you send the images, maybe your messenger or your tool requires smaller size of image. So some tools will compress the data. So from 20 megabyte, it can be reduced to 10 megabyte. Or maybe from 10 megabyte, it can be reduced to 2 megabyte. The picture is still the same, but the pixel, okay, the pixel of the picture is reduced. So there's the data compression. Data transformation. So there are some concepts about normalization and concept hierarchy generalization. So yeah, we can learn later of those things. First, let's deal with the data cleaning. So in the data cleaning, we can say that the data in the real world is dirty. And lots of potentially incorrect data. For example, we have the instrument faulty. So it means there are some faults on the instrument. Human and computer error. Transmission error. So those kind of errors, they can produce missing value or incomplete data or noisy data or inconsistent data. Yeah. Or maybe we have the intentional data. What is incomplete data? The data is incomplete because it has lack of attribute values and it lacks certain attributes of interest. Okay. And it can contain only the aggregate data. So we want to get daily data. For example, you know, in the stock, okay, in the stock company, if you are doing the investment in stock, the stock will be only on Monday, Tuesday, Wednesday, Thursday, Friday. How about Saturday and Sunday? No data. Okay, so if the data can be said as incomplete, we don't have the data on Saturday and Sunday. So how can you do the analysis? Yeah, of course, you need to do something for this incomplete data. Or for example, when you do the questionnaire, so you ask to the person, what is the occupation? What is the job? Okay, but maybe the person do not want to share the job. So he or she put missing value. You keep it blank. So this is a kind of incomplete data. Noisy data. So the noisy data, yeah, is noise or errors. It can also be an outlier. Yeah, for example, salary is -10. Yeah, of course, this is error. Yeah, there will be no negative value for salary because salary is start from 0. It's never starting from minus. Inconsistent. Okay, so I think we already learned something about this inconsistent, like the date format. But instead of the date format, the inconsistent can be related to the discrepancy in codes or name. For example, I have the attribute age and I have the attribute birthday. Okay. What is the age? Okay, the age is 45. Okay, but what is the birthday? The birthday is, oh, January 1st, 2015. Do you think is it right? Okay, it's inconsistent. If the birthday is 2015, maybe he or she is now like 6 or 7 years old. Okay, but why 45? So it is inconsistent. Okay. Or when you have the rating, so you want to get feedback from customers. So first you ask the customer, what is the best what is the best expression about my product? 1 is good, 2 is normal, and 3 is bad. But some people think 3 is good, 1 is bad. So you change the value. Okay, it's better to say A, B, C. A is good, B is normal, and C is bad. But when you change this one from 1 to 3 to A, B, C, it is inconsistent because they are different. Okay, so this kind of inconsistency in the data, okay, can happen, and you need to do something intentionally. It disguises missing data. Let's say some people, they do not want to share the birth date, okay, because the birth date, okay, the birthday is very private. It's a privacy issue. Then instead of giving the correct date, people just say blank, or they put January 1st. Okay, so January 1st for everyone's birthday. So it is intentional, and this is related to the data cleaning. Okay, Shelly. So when we have the incomplete or missing data, data is not always available. So the data have no recorded value on some attributes. For example, customer income. You may have some issues when the customer do not want to share their income. Missing data may be due to function errors in the equipment. So we call it malfunction. Inconsistent with other recorded data and thus deleted. So we already see like the inconsistent in the birth date. Do not enter the data not entered due to misunderstanding. Okay. Or certain data may not be considered important at the time of entry, or not register history or change the data. So this kind of things may happen to make the incomplete data. So missing data may need to be inferred. So we need to understand how we can replace or how can we do something for this missing data. And the assumption about the missing data, in most problems, the data is arranged in the rectangular data matrix. So we assume that we can make a kind of table or rectangular data matrix, and we can see some missing value. For example, like this one. So this is missing value, this is missing value, this is missing value, this is missing value, and so on. So the question mark is the missing value. We have row number 1, row number 2, row number 3, and so on. So this is the instances, and this is the column 1, column 2, column 3. So these are the attributes. Okay. And how to handle this one? So there are 3 things that I want to share today. So first, how we can do something to handle the missing data by ignoring the tuple. Do you know ignore? So if you have one row, so tuple, do you still remember tuple? What is tuple? Tuple. It can be row, it can be called as instance, it can be called as sample, it can be called as object. Okay, so you already learned from the previous chapter. So we can remove or we can ignore that row, we can ignore that sample, we can ignore that instance. So this is usually done when the class label is missing. So if the class label is missing, then we can just ignore it. So it means just remove it. Okay. However, this is not effective when the percent of missing values per attribute varies considerably. So I will explain why I mentioned this keyword. Fill in the missing value manually. So let's say if I have missing value, like what I explained before, if the birthday is missing, I want to put January 1st. I put January 1st intentionally, because if it is missing, I cannot do the data analysis. But if I fill in, I can fill in manually and based on my understanding. It is tedious. Okay? Tedious means time consuming, and invisible. Okay, invisible because if all the data are January 1st, what happened? It's not that feasible for the data analysis. let's say you want to analyze who will get the credit for bank, who will get the loan from bank. So someone who can get loan from bank is someone who are older than 20 years old. But the 20 years old are based on today. If you put the January 1st, then yeah, it's not feasible for doing that kind of condition. Or we can fill in automatically. What does it mean by fill in automatically? Yeah, we can set like a global constant. Okay? So in the global constant, yeah, you can say unknown. So put all the missing value as unknown. And this is another problem will appear. Or we can put min. This is the most common way. Okay? If the attribute missing is numeric value, so we can fill the missing value, the numerical value, with the average or mean. Or we can check with the mean for all samples belonging to the same class. Okay. So last time we already learned about the iris dataset. Do you still remember? Okay. The iris dataset, we have 3 kind of flowers. What are they? You still remember? Yeah. No, remember? So we have Setosa. Okay, Setosa, and then Virginica. Okay, and then Persicolor. Okay, that's good. You. Thank you. Okay, so we have 3 classes. Okay, and if I saw that there are some attributes of Setosa is missing, then I can find the mean, or I can find the average of that particular attribute and replace the missing value with the mean. Okay. Or if you want to do smarter way, yeah, we can use like Bayesian formula, or we can use decision tree. Yeah, so we will learn about that decision tree. So for example, what is the probability of an adult male to get salary $5,000? Okay, so yeah, we can make that kind of probability. Okay. So for example, okay, if I want to ignore the data, so ignoring the data means I want to ignore one tuple. I want to ignore one row. Okay. Now let's see. I have 3 trial data. This is the first data. Okay, so just say like this is the first data. This is the second data. And then this is the third data. So the trial one means, yeah, I did to 10 people some experiment. So the individual means the person is doing experiments in 4 attributes: y1, y2, y3, and y4. And every experiment, I will write down the result. For the individual one, okay, NA. NA means not available. NA, NA, NA. Oh, okay. The individual one has no available data for all attributes. The individual number 2 has no available data, only on 2 attributes. Then if we ignore the tuple, what happens? And we can ignore this tuple. Okay. If we ignore this tuple, it means, yeah, we eliminate the individual 1 and 2, and we will have 20% loss. Okay. Why 20% loss? How many rows do we have? We have 10 rows. Okay. And then we have 8 rows that we keep. Okay. And we have 4 columns. So the total cells that we have is 32. Okay. But the total is we have 40 cells. Okay. In this case, we have like, yeah, 20% loss because we have 8. We have one. Yeah, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 data are deleted. So 8 among 40, so is, yeah, is 20%. Okay. So if we ignore the 8 data, yeah, we have 20% loss. What about in trial number 2? Do we need to delete the row? Oh, if we delete the row, what happened? We have a lot of data deleted, and it is not good. We have only very small data, so it means we have only 4 multiplied by 4 for our analysis. So the alternative is to eliminate only the y1. Okay, so we can just eliminate this one. If we eliminate this one, then we have like 20%, 25% loss. Okay, because we still keep 30 data, okay, and 10 data is removed. Okay. What about the trial 3? Oh, this is more challenging. How can we remove the data? If we do not want to replace this data, how can we remove it? Then, yeah, if you delete this one, if you delete the column, what happens? You have only the column y4. It is only 10 data. If you delete the row, this one, you will keep 4 multiplied by 4, which is 16. So which one is the best? Of course, yeah, I want to choose the highest one, the 16 data. Right? Okay, so I do not want to choose the only 10 data because it's too small for our analysis. Okay, oh, thank you. Yeah, thank you for the answer. So we will choose the 16. But still, if we choose the 16, it's very less data for our analysis. So usually this kind of ignoring or the deletion of the cases with missing values, yeah, we can do this one. But if the data is very small, it's better to fill in the data. Okay. How can we fill in? So yeah, these are some issues. If we fill in manually, like this one, Brian, male, he lives in Yongin province. Oh, there is no such information on this province. How can we handle this one? Oh, yeah, maybe I know this is from Gyeonggi, but the database cannot understand. Okay, so we need to fill in manually. Gyeonggi. What about this one? Oh, sorry. Oh, I have some inconsistency. Oh yeah, I have some inconsistent example. I'm sorry. Please remove this, the second example. Okay, this is not consistent. The name city is Gyeonggi. It's not consistent. Okay, so if you can see DOB, date of birth, here there is no year. Okay, so maybe this is based on the American style. Okay, month, date, year. So month, May, date is 4, but what about the year? There is no data about year, so I can just put manually. I assume that okay, they are in the same year because they are in the same database. That's the way we can do to handle the missing value, is manually. If you ask me, it's not correct, right? Yes, it is not correct, but that's the best we can do. Or we can fill in automatically. Okay, as you already see before, yeah, we can use the unknown, or we can see the mean, we can see with some Bayesian formula, or we can use the attribute mean for the same class. Okay, for example, if Brian he live in Suwon and then Jessica live in Yongin, Bob, what about Bob? Do you know where he live? It's difficult, right, to understand, so I can just put unknown. So I put unknown to replace or to fill in this city name. What about the age of Charlotte and Eden? Missing here. Then I can calculate with a very simple mean. So 20, yeah, plus 23 plus 22. So we have this existing value. And then, yeah, after that, yeah, I can just divide by 3. Yeah, this is 21.6. Is it right? I guess, yeah, it's that value. And then I can put this value 21.6 into this 8. Okay. So I just assume that the 8 is 21.6. Or if you want to remove the 6, yeah, you can assume that they are 21 years old. Or for example, this one, this is missing. Then how can I fill in? Yeah, there are some ways. There are some intuitive way to fill in this data. For example, maybe there is a high probability that the male here, they are live to do hiking. But for female, oh, it seems here we have seen the pattern. Female, they love to play piano. So I think based on the probability, Jessica can be the hobby for the Jessica can be piano based on the probability. Okay. So with this kind of data handling, then we can have the full data, and yeah, you can do with the further data analysis. Okay. Okay, so how many methods are there to handle missing data? We have 3. What are they? The first is ignore the tuple. Second is fill in manually. And the third is fill in automatically. Okay. And when you fill in the missing data automatically, what kind of measure is good for numerical value? Mean or minimum or maximum or standard deviation? Which one is the best? Okay, that's correct. Okay, the answer is mean. Okay, thank you. Okay, thank you for your answer. Okay, when you fill in the missing data automatically, what kind of measure is good for categorical value? Mode, mean, median. If it is categorical value, can we get the mean? No. Okay, there is no mean for the numerical categorical value. Median, is there any median for the categorical value? No. Okay. What about mode? The most frequent value. Okay. So this is the most possible way. So what we see from the previous example, yeah. So the piano is the categorical value, and piano happens in most of the female. So yeah, we can say it is the most frequent value or the mode. Yeah. Then yeah, we can use mode to indicate this is one of the way. Okay, but it's not the best way. Okay, and yeah, we have another issue with the data cleaning. We already saw before about noisy data. What is noisy data? So the noisy data means I have random error or variance in the measure variable. So the incorrect attribute values, yeah, may be due to the faulty data collection instrument, or maybe the tools has errors, and then the data should be in the normal distribution, but suddenly it jumps, okay, or it goes down. Okay, it can be also data entry problems. Maybe when the operators are doing the job for the data entry, the operators are sleepy. Okay, for example, okay, or the data transmission problems. So when the data has been transferred using the internet, there are some internet connection errors, and so on. Okay, technology limitation, inconsistency in naming convention. Yeah, so that kind of issue may cause the incorrect attribute values. So some ways to handle the noisy data is, yeah, this one. We can use binning. Okay, I will explain the details about the binning, but the idea is we want to sort the data and then do the partition. Partition means I want to make groups. Okay, and the groups is based on some rules. For example, the rules is based on the equal frequency. So we will learn more about these things. Okay, or we can smooth it. For example, we want to smooth by means, or we want to smooth by pin median, and etc. Okay, so we want to make pin. Pin is a kind of place like this one. Okay, so we want to make it as a pin, something like this. The second one, we can do regression. Okay, if there are some noise, we can just make a regression and then do the fitting. Okay, so the fitting means I want to use this line to make the adjustment or smoothing of the data. Clustering. This is another way. So we will learn in our data mining course how we can detect and remove outliers with clustering. Or we can combine computer and human inspection. Yeah, this is another way you need human to be involved to check whether the data is noise or not, and then you need to maybe plot on the visualization, okay, and then if the expert or the human say, oh, okay, this is outliers, then you can just remove the data, okay. When you do the data cleaning, okay, so we need to understand that data cleaning, it is a kind of process, okay. We can detect the data discrepancy. What does it mean? When we want to detect the data discrepancy or the data gap, okay, data discrepancy means the data gap. There is a gap between one data and the other data. So we can use the meta data. What does it mean? We have the metadata by using some kind of domain or maybe some range or some dependency or some kind of distribution. Okay. So for example, we want to check the uniqueness, or we want to see the consecutive rule, or we want to see the null rule. Okay, maybe it's a little bit complicated word, okay, but let's say, for example, if you know the data scrubbing, the data scrubbing in some tools are available, and it used simple domain knowledge, for example, postal code, okay. So when you input your data about your address, when you go, like say in Kupang or in your online shop, when you put your address, okay, Doromyong, okay, when you input your address Doromyong, and then it will show you automatically the detailed address and the postal code. So we have that kind of things as the data scrubbing. Or spell check, okay. When you type something, if there is an error, then it shows you with the red color. So it means like you spell wrong spelling on your word. Okay. So that kind of things we call data scrubbing or data auditing. So we can analyze the data to discover rules and relationship to detect violators. Of course, yeah, it requires more things to do this data auditing. Okay. Okay, I think I will stop here. So